Hello. I understand that I'm probably the person standing between you and the pub. I will try. And yes, like thanks for the previous speaker. It will be pretty hard to match the level of details and stuff. But luckily, like because you know the pub and good weather and etc. So just chill. This talk is really like rather high level and thought provoking. Hopefully. So, a super short introduction. Like, my name is Anton. I took this headshot today morning because my wife is a photographer. I'm from Eastern Europe. That's why Anton K. So because it's unpronounceable. I run platform engineering and architecture at the company called Actable. We are building software for hospitality industry. So if you're staying at a rather fancy hotel, chances are that the staff of the hotel is having our application installed on their mobile phone. So, before I dive into the topic, I would like to tell a story. But it will be my personal story. So I've been doing this for I don't know, almost 2 decades. And as everyone, I started as a junior engineer. And when I was a junior engineer, it was a really funny story because the day before the interview, I didn't even know the language. And the recruiter, how are you trying to do this? But, I was a student. And if you're a student, you just read the book overnight and next day, you're fine. So I joined, I succeeded. I joined the company. We were doing mobile games in Java, but the phones at that time had buttons, physical buttons, and the size of the jar was 30 kilobytes, so really not fun at all. I spent most of the time, because I was a junior, just starting my career, most of the time I spent learning the language, learning the ecosystem, trying to figure out how to navigate the industry at all. I was taking punches from lead engineers. They were laughing at my code. They were telling me that I will not make it. Nothing of that mattered. The biggest thing there was that when you're a junior engineer, no one cares about your opinion. That's all. That's your state of affairs. Later on, I wouldn't say that it took me days, weeks, months. It took me some time. I figured some things, and I was promoted, so I wasn't a junior anymore. The title, the responsibilities, level of autonomy, it really didn't matter. The biggest shift that happens when you transition to a more advanced career is that they're starting to invite you into a room where all the brainstorming is going, when they are trying to figure out a solution, when they're thinking about how to overcome challenges and stuff. And I was invited to that room. That was really nice. They even asked for my opinion, finally. The thing is, they didn't take it into account. They were always going with someone else. And I believe a lot of people probably could relate to that. You're in a room, you're discussing a problem, you know the answer, you have the solution, you have this gut feeling and etc. And you just cannot sell it. You cannot sell it to anyone, and they go with other person's solution. And eventually, when that solution, because it is the other person, of course it was wrong, it fails, and yours, and you told you, but still it doesn't give you much credit. I didn't like the situation. Of course, it was not black and white, so it wasn't all of my ideas were shut down, but it was ranging. Obviously, it was increasing over time, but I was not really super happy with the level of accepting my solutions. So I was no, this is not sustainable for me as an engineer. I want to improve my career. I want to make a dent in the industry. How do I do that? I promised to myself that if I am in the room and we are solutioning, I will never ever be in a situation where I cannot explain why I think I'm right. Because I figured that The problem before was not my solutions. Most of the time they were right. Sometimes they were, of course, wrong. But it was me. I wasn't able to explain why I think I'm right. And I figured, and nowadays, because I run multiple teams, this is what I tell them as well. Every time we are starting solutioning, we should be data-driven. We should make an objective decision. There shouldn't be like any subjective stuff like, I like this better. The word like is forbidden. So you need to make sure you checked multiple alternatives, you understand pros and cons, you understand the context, you have the data, you have the experience, and this and only this when you make a decision. So I promised to myself that I will be doing that, like I will try to do that. Of course, you know, I'm not perfect, so not always, sometimes I really push for a solution because I like it, but still. So let's unpack a bit how I approach this and, like, you know, what I figured over the years, how to not be that person in the room who has a solution but hard to get a buy-in. Yes, it's Grok. And it is really terrible at generating images. So the problem, like if we unpack the problem, it's you don't have experience, that's why you cannot explain yourself, that's why your solutions are not being considered, that's why you don't get experience. So how do you get experience if you don't have experience? You practice, like practice makes perfect. And this is this well-known, probably, like we heard this multiple times throughout our lives in different settings, the rule of 10,000 hours. Like the thing is, someone smart figured out that by the time when you master a specific craft, usually it means that you already spent around 10,000 hours doing this. And it's not a rule, I try to name it as a rule, but actually it's like a principle, pretty universal one. So if you want to master a thing, you just do it, you repeat, you learn, you need to get feedback, and after 10,000 hours, like after some time, hours really don't matter, you make it work, you become a professional in that. And this really applies to a lot of things. It applies to, I don't know, flying a plane, playing music, doing UI design. Like for example, as a UI designer, what do? You first like provide some mock-ups that no one can comprehend what's that. You get feedback, you iterate, and after some time you produce the masterpiece and you produce stuff like liquid glass. So yeah, there are exceptions to this rule. But actually, are they? The thing here is like let's go deeper into this rule, because like what this rule means is that you do deliberate practice. You have a like gray area gap in your skills. You figure out, okay, I need to repeat to learn, and I will become a pro. I will become a master in this thing. So you repeat, do the same thing a lot of times, and hopefully, you know, it works out for you. So a question to the audience, as a people who write code, how many of you repeat the same thing multiple times? Bad for you, you're doing it wrong. Probably. Sometimes it's important. If we try to structure this a bit more, what deliberate practice and the continuous iteration means is that, and it's pseudo Kotlin, so you know, don't try to make sure it compiles. As long as you iterate more and more, the variance between the ideal outcome, you know, approaches zero. So if you're flying a plane, every time you take off, you do it exactly the same. You do it with the perfect trajectory. If you're playing the piano, if you're playing the music, after you master the piano, it means that every time you play the same song, it's indistinguishable from every other attempt, because you achieved the mastery, and so you achieved repeatability. So in simple words, as I said, deliberate practice is trying to minimize variance. Probably variance, like minimizing variance in software industry is really not a thing. And if anything else, our projects probably maximizing, randomizing, doing whatever to this variance, except trying to approach it to zero. And it's super simple. Like if you're a product company, you don't want to clone, to copy your competitors. You really want to have a differentiator. You want to strive in the market. You don't want to be copycat. It's like, doesn't make sense for a business. If you're in an agency, and working not on your own products, but someone hires you for that, chances are that those clients, they will be from different industries. They will be trying to hire you for solving different needs, and still it will be like a lot of variance in the project that you are doing. What do we do instead? And it really took me an hour to teach Grok to do this line. And actually it tricked me. Funny story. Once I managed to have this line, only next day I noticed that it changed the words. So I had to spend one more hour to fix it. So instead of deliberate practice, I think it will be more valuable for you to do deliberate learning. And what's the difference? The difference is that instead of minimizing variance, you try to maximize exploration. You explore, you learn the unknowns. You try to figure out, like, what is the thing that I don't know yet? What are other things that I can learn? You explore and you discover a lot of stuff. And this code is also AI generated. It's breadth first search in a graph. So which, goes into breadth, not into depth. And let's see what the next slide has. The very best thing to do that is what you're doing already. You attend conferences, local meetups, you listen to different opinions, you discuss those opinions in a pub, and of course, like, you need to share. You need to share with each other. You need to just, listen, ask, share, all the kind of stuff that you're already doing, so you're ahead of the game compared to those others who are, I don't know, just chilling at this nice weather. But that's only the first step. And what can we do else? What else can we do? For that, I'm applying this exploration for many years, and a few years ago I stumbled upon a really nice book called The Goal by Eli Goldratt. This book is about applying theory and constraints, and here it's actually a novel. There is a version of a graphical novel, there is a version of just text, where he shares a story about a person who was tasked to run a production facility. And this production facility has only 30 days because it's already having a lot of losses. The management is thinking to shut it down, so they are giving the guy a chance. And of course, it's happy ending, so the guy manages to do that. But the way how he approaches that is that he's not trying to optimize every specific step of the factory manufacturing process. He zooms out and looks at the flow. And the person, the hero of the story, he tries to maximize flow. He tries to make sure that there are no bottlenecks. And actually, this is what we call DevOps culture, or like agile methodologies. But this is written in the previous century, 1994, so for manufacturing. So cool stuff. Another thing that Eli shares throughout his wisdom is that he says that, and it's written here, a technology should only be adopted if it addresses a specific limitation of the system. And I want to emphasize that you don't apply a technology if it does not address a limitation, and if it doesn't address like one specific limitation. And if we want to rephrase this and dive a bit deeper into that, there are 4 questions that came out of this thought that you can apply when thinking about adopting a new technology. The first one is, what is the technology's impact? What does it really do? And for example, like because we are at the engineering conference, like talking Android, like a good example here might be Compose multi-platform, for example. Compose multi-platform, what does it do? It allows you to not touch Swift and that stuff. You write Kotlin, you use your familiar APIs, and it just works. The second question here for adopting a technology is there any limitation that this technology is addressing? What is this limitation? And you can rephrase it as, how exactly does the technology work? For Compose multi-platform, the answer is pretty obvious, and it is very close to what Compose is actually doing and what Kotlin multi-platform is actually doing, so no need to come up with random things here. The third question is, like, if there is a limitation, it means that over time we figured out some rules around this limitation. Like, how do we cope with that? How we work around with that? And in case of cross-platform mobile development, if it's not available to us, then what do? We hire an Android team, iOS development team, and like we need to have multiple teams, they need to talk to each other. If we are to try to adopt any cross-platform technology, then like probably it's Flutter or React Native, so we hire Flutter team, but we still need to have some experience for Android, for native Android and for native iOS, because none of the cross-platform technologies except one are perfect, and there is still a small amount of native code that you need to write. And here goes the most important part, the part that a lot of people are missing. Let me use a bit different example here. Many years ago, before the computers are here, every production facility had to do a very specific thing. They needed to plan their production, and they needed to plan the amount of materials they need to purchase to actually produce the goods that they're producing. And because computers were not there, they were calculating this manually. And I don't know, we can say that it might have been taking like a week of manual work, to calculate all that. And because it was manual work, it was error prone. So you need to recheck that, and then cost of error is a mistake in this kind of thing is pretty substantial. So like if you miscalculate and purchase more materials, then you have leftovers that you already paid for that probably you don't know how to use. They're occupying storage spaces. If you underproduced, then you don't deliver to your customer, and it's reputational losses, it's like potential refunds or something. So in order to find the balance, if it takes you a week to calculate all this stuff, probably you are not planning for a year, for a quarter, maybe for a month or so. Like if you plan for longer, the likelihood of a mistake is higher. If you plan for shorter period, it's just economically not feasible because you need to spend 1 week. So the technology that all those companies adopted was MRP, Material Resource Planning Systems. So with that, the thing that changed the industry was that now, instead of 1 week, you can calculate all this stuff overnight. So let's imagine that you're running a factory, in a manufacturing facility. You're producing smartphones. You're purchasing a lot of like CPU, RAM chips, glass, whatever. And finally, instead of 1 week of manual work, you can calculate all the required stuff, like how much of things and when you need to purchase to produce your smartphones, Like if you can do it overnight, like what would you do? Most of the leaders would say, oh, nice. Like I cut the human element. I don't pay the salary. I let them go. I save some money for my company. I share this win for the shareholders. I get a bonus, and we are done. Actually, the most important thing to do is to understand the new rules. Every technology, once it lifts a limitation, previous rules don't apply. But there are new rules. For example, if you can finally calculate all the necessary things overnight, it means that you can deliver smaller batches. It means that you can transform your customers' requirements from your customer. Like your customer don't need to tell you, in the next month, I need 1 million of smartphones of this model and like 2 million smartphones of that model. Your customer can change their mind. They can ask for more, ask for less. They can call you and say, sorry, this doesn't apply anymore. And for you, it's just, you recalculate stuff overnight. You can easily respond to change. And you don't need to get in a room with your customer to get all the requirements carved out on a document that you sign. And then you don't need to go into a room with your tech leaders and brainstorm and do the big design up front. So yes, now I started to talk about Agile. Let's see what's next. So why does it matter? It matters because, like, I'm talking about exploration. I'm recommending to, instead of repetition, instead of deliberate practice, to do deliberate learning. So explore, 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 learn more. And what we can, like, the pushback that I can receive for that is, but there is so many stuff, and I just cannot comprehend that. And like in my area, the stuff that I can learn might be actually limited. So what do we do? And throughout this presentation, I try to use random examples and to show you that it doesn't matter from which industry the example is. Like the MRP thing is similar to Agile. The goal book is similar to DevOps culture. And there is a lot more. And why I'm showing you this quote, because like I'm emphasizing that any technology that you see in Android development, if you zoom out in software engineering and maybe in some adjacent fields, a good technology that is worth exploring is doing only one thing differently. And your goal is to simply identify what it is doing differently. And once you figure out that, you have an additional tool in your pocket, like in your toolbox. And when you're in a room with other leaders, tech leaders of your team, you can now share experience, like share a broader experience, bring a lot of more stuff to the table. And because it's 2025, oh no, I forgot about this slide. So this is an example. I want to show some examples of like why I believe the domain and the specific industry inside the software engineering is not that relevant. To the left, it's web. It's a single-page application, Angular. And to the right, it's Compose Vue. It is the same thing. Like literally the same thing. When JavaScript started to make our HTML pages dynamic, what changed is that they allowed to write some custom code. When we had Android legacy XML views, it was a static thing, like static HTML in ancient times. With Compose, we still are declarative, but we can do conditions and we can run some code. And the same thing applies, I don't know, let's say Node.js and JavaScript runtime, it's single-threaded. So you don't have issues with multi-threading, all the concurrency and stuff. But how does it work? JavaScript runtime runs piece of your code, and once your code starts like needs to wait for I/O or for like external thing for interaction with the platform, it gets paused, and another task, another piece of code gets executed. This is Kotlin coroutines. And like when we are doing Android development, we are using Room database library or SQLite, directly. This is the same database that is being used on the backend. So we can apply things from different points, like from different technologies, from different domains, because the real application doesn't matter. This one thing, this one differentiator, this is what is the culprit. And hopefully, yes. 2025. Why? I think it is the best time to apply deliberate learning, because we have AI. For this presentation, I think that's what I wrote myself. All the pictures, the code, I just tasked Grok to do that for me. Not because I'm lazy, but because it's not that important detail. Like the message of the presentation is different, and like whatever language I use, how specifically I phrase and design my slides really doesn't matter. Though, so you just open ChatGPT, GitHub Copilot, Juni, Julie, all the other names, and you simply like, I want to learn how databases work. Tell me, and you learn. And you will find there things, like the algorithms powering the databases. And you will see hash tables there. You will see lists. You will see all the stuff that applies to JavaScript, even to JavaScript, and even the technology that we are not allowed to say here. Important thing. Today in the morning when I was refining this presentation, and I promise that's the last slide, it's like 22 hours ago, MIT published a research saying that if you rely on ChatGPT too much, you become dumb. Physically, unrecoverably, your neurons die. And before that, before I saw this, actually this version of a slide was something around like, there is this guy on the internet, on the YouTube, he calls himself the Primagen. Maybe you know him, maybe not. He once explored, like he gave a stream about ChatGPT, and the message that he was saying is that if you're running to your goal and there is a hole, if you don't know nothing about the domain, ChatGPT or any other LLM will build you a bridge. And you will cross this bridge and you will achieve your goal. But the size of the hole, the learning that you didn't do, will be enormous. And next time you will not be able to do it without an LLM. And the best usage of AI here, and this proves, this is the same stuff that this MIT paper says, you need to be smart in general, you need to know your craft in general, and you need to use AI to learn, not to delegate tasks to it, but to learn. Like, I think that Angular web SPAs work differently, or work the same stuff as Compose. Please explain me, please show me how it is done. It writes you the code, and then you should ask, why? And like, I don't understand this line, tell me. If you do it like that, then ChatGPT will like just, soften the corners, allow you to move faster, but still don't take away the learning from you. And so that's super important. Learn, learn, learn. That's it. That was the last slide.